For the next question in our tutorial, we are going to focus on the enantiomers. Okay, so if you look at the question, okay, from the following list, okay, we are given a list, okay, identify the compounds that exhibit optical activity. Okay, so optical activity is an ability of a chiral compound to rotate the plane polarized light. Okay. If the compound has a chiral carbon or a chirality center, it means that the compound is an optically active because it can rotate the plane polarized light. So for the compound that exhibit optical activity, you have to mark the chiral carbon with the asterisk and draw a pair of enantiomers using a 3D structure. So, how do we identify whether the compound has a chirality center, or we can call it as a chiral carbon? Okay, so first, that carbon must be an sp3 hybridized carbon. Okay, that means that carbon have 4 single covalent bond attached to it. Okay, so there is no double bond, there is no triple bond. Okay, the sp3 carbon must have 4 single bond. Second, okay, that on that sp3 carbon, it must attach to 4 different atoms or group of atoms. Right, so there are 2 requirements for the carbon will have a chiral center, a chirality center. First, it must be an sp3 carbon. Second, that carbon must attach to 4 different atoms or group of atoms. So let's have a look at the first structure. Okay, so first we are going to identify the sp3 carbon. Okay, for this carbon we have 3 hydrogen and 1 carbon. If you can't see it, you may expand the structure a little bit. Okay, but if you can see it, okay, you can see there are 3 hydrogen and 1 carbon. So yes, this one is an sp3 carbon. Okay, but for this carbon, since we have a carbon-carbon double bond, so this 2 carbon is not an sp3 carbon. Okay, but this carbon is an sp3 carbon. This carbon is also an sp3 carbon, and this carbon is also an sp3 carbon. So let's take out the one that in the bracket here. Okay, let's say if I convert this structure into skeletal structure. So this structure will look like this. Okay, so this one is sp3 carbon, this one is not, this one is not, this one is sp2 carbon, sp3 carbon, sp2 carbon. Okay, so we won't look at these 2 carbon because it is not an sp3 carbon. Our each sp3 carbon here, 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 and here. Okay, so this carbon, since it is attached to 3 hydrogen, so it is not, it is the same atoms, so it is not a chiral carbon. Same goes to this carbon. We have 3 hydrogens, so no, it is not a chiral carbon. This carbon has 2 hydrogens, so no, it is not a chiral carbon. And also this carbon got 3 hydrogens, so no, it is not a chiral carbon. So this compound, okay, is optically inactive. Okay, optically inactive because it does not have a chiral carbon, so it cannot rotate the plane polarized light. For the second structure, okay, again, I'm gonna change this structure into skeletal structure. Okay, so we have 4 carbon. Okay, on the carbon number 2, we have 1 OH group. Okay, so let's identify the sp3 carbon. So this one is sp3 carbon, sp3 carbon, sp3 carbon, sp3 carbon. Okay, but this carbon got 3 hydrogens, so no, it is not a chiral carbon. This carbon got 2 hydrogens, so no. 3 hydrogens, so no. But on this carbon, we have 1 OH, 1 CH3, 1 hydrogen, 1 CH2, CH3. So this carbon got 4 different atoms or group of atoms attached to it. So we have 4 different things on this carbon. So this is a chiral carbon. So we are going to label it by using asterisk. Since this molecule this molecule has a chiral carbon, so it is optically active. Now we can draw the enantiomers of this structure in 3D. So focus on this carbon. Okay, so I'll take out this carbon, the asterisk carbon. Okay, in this carbon, okay, sp3 carbon, the shape of sp3 carbon is a tetrahedral. So we have two solid line indicates that these two atoms or group of atoms are on the plane. Okay, and then we have a wedge line. Okay, a wedge line. Okay, indicates that atoms or group of atoms are in the front. And one more, we have a wedge dash line. Okay, indicates that atoms or group of atoms are on the back. So now we have 4 bonding on this carbon. So we are going to put the hydrogen, OH, CH3, CH2, CH3 on this bonding. Okay, so you can put anywhere you want, but the most complicated one is suggested to put here. Okay, so we have CH2, CH3, the most complicated one. So I'm going to put the CH2, CH3 here. Okay, and then I'll put the OH here, and then here I'll put hydrogen, and then here I'll put the CH3 group. Okay, so the enantiomers must have a pair to show that it is a mirror image. So the mirror image of this structure, so I'm going to draw again. Okay, so we have a solid line, okay, and then we have a wedge line. Last but not least, the wedge dash line. Okay, so just copy back everything. So we have CH2, CH3. Here we got hydrogen. Here we got the CH3. And here we have the OH. So these two must look as mirror image. Okay, so we have OH. And then here OH. For the third structure, so again, I'm going to convert this structure into skeletal. 1, 2, 3, 4, 5 carbon. Okay, so 1, 2, 3, 4, 5 carbon. And the third carbon, we have 1 Br. So this is an sp3, 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 sp3 carbon. Okay, but this one got 3 hydrogen, 2 hydrogen, 2 hydrogen, 3 hydrogen. So it is not a chiral carbon. For this one, we have 1 hydrogen, 1 Br, but these two are identical. So we have CH2, CH3, CH2, CH3. So this structure is optically inactive. It does not have a chiral carbon. So we don't have a chiral carbon. So it is optically inactive. For the next structure, 1, 2, 3 carbon. Okay, we have 3 carbon, where the carbon number 2 we have the NH2 group, and then for the carbon number 3 we have C11O OH. Okay, we have double bond OH on the third carbon. 1, 2, 3. Okay, so now the sp3 carbon is only for this and this carbon. So since this carbon is an sp2 carbon, so we don't have to look at this carbon. Okay, but for the first carbon we have 3 hydrogens, so no, there is no chirality center. Okay, for the second carbon we have NH2, H, CH3 and COOH. So yes, we have a chirality center on the second carbon, so label it by using asterisk. And now we are going to transfer the atoms or group of atoms that attach to our chiral carbon here. So we have hydrogen, okay, and then we have CH3, NH2, and also the COOH. Okay, so here same with here we have COOH, H, CH3 and also the NH2. Okay, so this is our enantiomers in 3D. For the last structure, okay, so we have sp3 carbon, not sp3, not sp3, sp3 carbon, sp3 carbon, sp3 carbon, and sp3 carbon. So since we have 3 hydrogen here, so not a chiral carbon, 2 hydrogen, not a chiral carbon, 2 hydrogen, not a chiral carbon, 3 hydrogen, not chiral carbon. But for this carbon, we have 1 hydrogen, 1 bromine, 1 CH2CH3, and the other one is this big group. So yes, it is optically active, and then we are going to label our chiral carbon by using asterisk. Okay, and again transfer the atoms or group of atom on our chiral carbon here into these two. Okay, so I'll put the hydrogen here. Okay, bromine, and then we have CH2, CH3. Okay, so be careful, make sure this carbon is attached to the CH2. So if you look at this carbon is attached to CH2 and then CH2 is attached to CH3. So here we have this carbon attached to CH2 and then we have CH double bond, okay, and then we have CH and CH3. Okay, so just copy back everything to our second structure. Right, so here we have hydrogen, we have CH2, CH3, and then we have Br. So this is our pair of